So, hello everyone. Just myself is Hiren, and I'm going to conduct this tutorial session. So we will just wait for 2-3 more minutes so everyone can join, and then after we will start. Meanwhile, can anyone say that am I audible and like
Yes,
uh,
sir. You are perfectly
okay,
audible.
Yes, sir.
okay, okay, fine, great. So I think we can start now. So I will just share my screen. So are you able to see my screen?
Yes, sir.
Okay. So hello everyone. My
Yes,
name is yes, yes. Okay. So am I audible to all of you?
Yes, sir.
Okay,
yes,
great.
sir.
Okay. So hello everyone. My name is Hiren Solanki, and I am currently a PhD scholar at IIT Gandhinagar. So, as a part of my PMRF fellowship, I'm conducting this tutorial session on Advanced Geomatics Engineering, which is offered by IIT, IIT Roorkee, and then the instructor of this course is Professor P.K. Garg. So before starting, I will give my brief introduction. So I am a third year PhD scholar in the from the Department of Earth Sciences at IIT Gandhinagar, and currently I'm working on application of deep learning and machine learning in flood forecasting. So that is my overall study area, and I'm conducting this tutorial session every Monday, 7 to 9 p.m., where we will discuss the basic questions which you already haven't been through in the week one's video lectures or for that particular week's video lectures. So we'll solve some numerical problems, understand some concepts. We'll go through some concepts one more time. I will show you the actual data sets, geospatial data sets of India and other countries, and how you can collect the various data from various sites, and then how to process those data sets into open source software such as QGIS and Google Earth Pro. So that's like how we are going to go through this course. And like if the meeting ends before 2 hours, so in those cases you have to join this meeting uh, like this like to doubt session while with the same link. Okay, so I think if after 1 hour, if this meeting gets over, then join the same session using by clicking on the same link. So that's all from my side. I will just request everyone just to give their small introduction, just their name and with their department and then college name, and then after we will start. Yeah. So I think you can introduce yourself. So yeah.
I Institute of at Department of Civil Engineering.
Okay. Thank you. Next one.
Good evening, sir. Sir, I'm Abir Bhunia from Physics Department, undergraduate student from University of Delhi, sir.
Okay. Thank you. Next.
Good morning, sir. Sanjeev
Yes.
Ranjan from Department of Civil Engineering, Central University of Jharkhand.
Thank you. Next.
Good evening, sir. Myself Naman Kumar from Civil Engineering, Central University of Jharkhand.
Thank you. Next. I think your audio is breaking, Murli. Okay, can anyone else introduce themselves?
Good evening, sir.
Yes.
Good evening, sir. Myself, Shivshankar Roy. I'm a second year PG student at Geospatial Science Department of the Burdwan University, West Bengal.
Thank you. Anyone
Good
done?
evening.
Yes.
Yeah. Good evening. Myself Rakesh. I am working in Indian Space Research Organization, and I am also pursuing PhD from Indian Institute of Space Science and Technology, Trivandrum. Thank you.
Thank you. Okay. So I think we will start now. So in today's lecture, what we are going to do is we'll go through the some of the question answers or objective questions from the week one's content. And then after, I will show you some of the sites where they have used geospatial data sets for various application-driven solutions. So we will start with the question. Uh, so you can answer the question by unmuting yourself, and then after we will discuss the right answer and the discussion on that particular question. Okay, so our first question, are you able to read the question? Are you able to read the question?
Yes, sir.
Okay, fine. And if I mean, no need to note down the things. We will upload this thing on Google Drive, so you can get the all these materials from there only. So first question is like you have gone through this course of geospatial engineering, and this is the course which is advanced geospatial engineering. So first thing when we learn this course is like, what do you mean by geospatial data sets? So here the first question is like talked about like what are the things which are included in the geomatics engineering or not. So I mean, if we know that when we talk about geospatial engineering, it is all about the collecting the various data sets related to the earth. So it's like geomatics. So geo means earth and matics means the measurements through mats. So we are collecting the data or measuring the earth surfaces. So and then after we are processing those geodata sets. So the first answer is right. Then we have development and management of database of geodata. So whatever the data we collect throughout the measurements, whether it is from the survey or some other satellites or from any kind of platform. So then we develop some kind of applications using those data sets. So we will be having too many data sets. We'll combine all the data and we'll create the database out of it. So that will be like, it is also considers the development and management of data sets of geodata. Then we have design and construction of structures. So can anyone tell me that is it included in geomatics or not?
No,
No.
sir.
Okay, no, why? Because we are talking about collection and the collection of the various data and its processing of geospatial data. Whereas here it is considering design and construction, which goes to the structural engineering part, not in the geomatics engineering. And that's why that C option is wrong. And we'll also look into the next option, which is the development and integration of geodata using computer tools and software. So right now we are having so many information communication tools and IoT based tools such as sensors. So many sensors are there. So those sensors and ICT tools will help you to collect the geospatial data, and then using those data sets we will develop the so many applications so that it will be useful to the public. So as you can see here in the figure that we have, whenever we talk about geomatics engineering or geospatial engineering, first we have data and maps. So we have so many data sets and those data are related to the earth. So we talk that data as a geospatial data, which is having the spatial information associated with it. So that's why we can pinpoint any data sets using latitude and longitude. So let's say if I ask you some of the things, let's say describes what kind of objects are near to you. So you may say that table is near, chair is near, laptop, phones, those are near to you. But at the point when I ask you that pinpoint the locations of the different objects which is near to you. So then we are introducing the space component, and then the exact latitude and longitude we have to specify of all those objects which are surrounding to us. And then we'll convert our information from normal list to geospatial database where we will associate coordinates of each and everything with the given object or phenomena so that we can track those things spatially. So basically those is about data, geospatial data, and then using that geospatial data, we will convert those data into maps so people can use it. Then once we have data and maps, we will develop the different geospatial toolkits and we will do the geospatial analysis, which is includes the network analysis or overlay analysis or proximity analysis. So in this course, you will learn all those kind of stuffs and how to do those kind of analysis as well. And then after, once we have database and analysis, then we will put those things into app format or web-GIS format so that people can use the data, they can explore, they can take the decisions from those data sets. So this is the chain of like how we work out in the field of geospatial engineering. So first is data collection, then converting those data into proper database, then analysis of the data and converting that into a particular portal, application or web-GIS platform. So this is the first question. Now we will move to the second. So the question is like ICT and IoT technologies are used in geometric engineering. So whether it is true or false. Can anyone say the answer?
No.
Yes, this statement is true. Why true? Because right now you are seeing that in any kind of applications we are having so many data sets. So how to process those data sets? We need some tools to process those data sets using our computer, laptops, other softwares. So it will come under the ICT tools. And then if we want to measure some things partially, let's say whether it is the air quality or the quality of water or the type of soil or any kind of parameter, then we need different kinds of sensor. And then the sensor will record the data automatically at the location where we cannot go or the very remote locations. And then once we have all the data sets, we can create some system which will give us the that whether the risk is going to come at that particular place or not. So in India, if you see the Central Water Department, like CWC, Central Water Commission, they are having the flood monitoring sensors. So what these sensors do is they have like placed this sensor along the rivers, and whenever the water level is increasing and whenever it will reach at the like a very some level which will generate the risk to the nearby population or the downstream area, then it will send the SMS to the community which are surrounding the 1 kilometer of the river or the which are in the downstream of the river. So we will send the SMS and other things communication so that we can avoid like improve the our disaster risk resilience. In that way, this ICT and IoT tools will work out. So, I mean, here I have given one example of floods. Let's say this river is passing through one of the city. So, what we do is using the geos like concepts of geomatics engineering. First, we will like delineate the river, or first we will measure the boundary of rivers. Then we will see what are the surrounding areas that river can go through. I mean, if the flood will come, what is the floodplain of the river? How far it can go? So we'll measure those areas using different kinds of surveys, using satellite imageries or the drone or LiDAR or so and so forth. After that, we will put our sensors at some of the locations which are critical to us. So let's say some sensors near to the bridge which are trying to connect the two parts of the city, or some of the near the municipality's office, or if any kind of children parks are there or bigger schools are there or area having more number of students and so on and so forth. So we'll identify the location and we'll put the sensors accordingly with the like depending on their importance and the risk level. Then after we'll measure the water level at all those locations, and if any kind of risk, if we observed any risk, then we will distribute the alerts to the nearby community. So for that, we need to use this GIS tools, remote sensing tools to observe the particular area, drone images. Then we have to communicate through the different servers so that to give the information from one place to another place. Then while doing this, we are collecting so many data sets, whether it is from drone or satellite imagery, it's a very big amount of data. If you want like one city, if you want to cover one city through the satellite images, it will take like for one day it will take 1 GB of the data sets. So like if you want to observe the last 30 or 40 years, it is very difficult to do all this thing in your normal computer. So that's why we have to learn like how to handle big data set through the clouds and other technologies. So those things will come under ICT tools, and then we have IoT tools, which are the Internet of Things, which are it comes under the smart sensors, smart infrastructures, monitoring systems, and then further the applications related to the smart city. So in today's lecture, we will see one of those kind of applications at the end of this class, which is the example of Gandhinagar Municipality Corporation. So they have developed their web-GIS based GIS platform through which you can monitor the different parts of the city and different assets of the city and how they are interacting with each other. So we'll go through it once. So this is like how we can incorporate the ICT and IoT tools in geomatics engineering. Now, any question till now?
Sir, IoT tools that are mentioned in the previous images are not
Yes.
clear, the four options.
So IoT tools means like Internet of Things. So what will like it's kind of first thing is like you are having water flowing through a river. Okay. Now you will put one sensor to measure the water level of the river. Okay. Then once it will give you the data sets of the what is the water level at each and every point, at each and every time, sorry. And then after you will construct the time series and you will combine the data of last 30 to 40 years, and you will check out that whether the current water level is at like a high risk level or high flood level or a danger level, and so on and so forth. And once it will cross the danger level, you will send the alerts to the nearby community. So I mean IoT tools means like collect the collection of data through the sensors and taking the decisions from that.
Yes, sir.
Anything else?
No, sir.
Someone raised their hand. So do you have any other questions? Okay, so now we will move to the next one. Uh, so now you have gone through the types of scanning. So like generally if I want to collect the data of Earth, like if you want to observe a hill or river, what will you do? So if you want to record something like what is happening, let's say if you want to see what is happening outside your window, what will you do? Can anyone respond? Like if you want to record or if you want to observe that what is happening outside your window, what will you do?
So I'll make a camera graphy.
Exactly. So you can use the camera. Very simple thing is we can put one person outside your home as a watchman so that he will observe the different things. If not, we are having surveillance camera. It will monitor the things which are happening in your surroundings. Now, this will be like tools which are useful to monitor your surroundings. Okay, but sometimes let's say if I will say that find out the slope of the terrain or find out the slope of the river. So whether the from that we will decide the what is the flow of river or what is the velocity of the water which is flowing through the river, or if something will come like a landslide or something will happen. So how the risk associated with that will become. So to do that, like we have to do different kinds of survey to measure the topography or the terrain. So for that, generally we use the surveying instruments such as digital level, auto level, total station. You might have heard about all those instruments which are useful to measure the terrain of the surfaces. Now, one tool is there which is known as a terrestrial laser scanner. So from the name, it suggests that terrestrial, it means it is kept on ground. So it is on land. As you can see in this image that one instrument is kept on a land. It is not on air like drone. It's not like a drone. It is not a aerial vehicle. It's on land. That's why it's known as a terrestrial. And laser scanner means it is using the concept of laser and it is scanning a object. So now if you scan the object which is in front of you or which is in front of the machine or in the surroundings of machines, which of the thing you cannot detect? So the options are deformation, buried object, inclination, and sinking. So can anyone give an answer on? Yes, buried objects we can't detect. Can anyone tell why?
So because the light can't passes under the soil.
Okay, so it cannot penetrate, laser cannot penetrate through the soil. Okay, so whatever is there on the like which we can laser can go and come back, that we can those kind of phenomena we can detect. So here it's written as a deformation or inclination or sinking. So like now can anyone tell me like what are the applications where you need to measure the deformations? Like as a civil engineer, what are the or civil engineer or if you are interested in finding out the deformation. So what kind of object or structures or the like that you want to find the deformation. So recently one big event happened, I mean at Delhi, if you might have heard of it, at Delhi airport. Can anyone tell about that thing which happened?
It's a flood disaster.
Yes. So can anyone tell like recently one thing happened at Delhi airport Are you like any one of you are aware about it?
Yes, sir. The Indira Gandhi International Airport at the terminal point that is destroyed.
Yes, so it destroyed because like that particular slab which was there, it fall down. Okay, so what is like if we want to measure the conditions of the different structures like that, so we have to use the scanners. Like the scanners will not used for normal applications. The structures we are like very like if something will break at that particular structures, then it will cause a lot of problem to us. So let's say one example is dams. So let's say if any kind of reservoir is there, let's say we take example of Sardar Sarovar Dam. So we will use our terrestrial scanners and then we will scan the surface of the dam. Now after 1 year, we will one more time use the terrestrial scanner and then we will scan the surface. And then we will measure these two surfaces which we generated from this terrestrial laser scanner. And then we will get to know that at which location it might have bulged out because of the pressure which is generated due to the water. So like that you can find out the different deformations which are happening on dam surface, and then you can suggest any kind of rehabilitation methods to avoid that dam failure. So for that this terrestrial laser scanner is like useful. Apart from that, inclination is there. So if two objects are like inclined with each other, so what is the angle at which they are inclined? So this will be useful. Like if you have heard about Archaeological Survey of India, then they found the different kind of excavation sites, and then they want to recreate or they want to make the digital structures of those ancient cities. Let's say Dholavira or Lothal or Harappan towns. So for that we use this kind of scanners and we'll scan the entire surface of the ancient cities, and either using the scanners or LiDAR system we generate the 3D models of those ancient cities, and then we can learn from those how was the drainage systems during that time, or how was the construction of building took place during that time, or the component way how various components have been there during that time. So those kind of things we can learn. And then sinking is like one of the another example. If we take example of bridge or pavement, so they sinks because of the traffic load or vehicular load. So that we can also find out using these lasers. And so I mean these are the different applications of terrestrial laser scanner. And for buried objects, we cannot use it because it cannot penetrate through the ground. But now if I ask you the question that what is the instrument which we can use to find out the buried object, then can anyone tell me the name of that instrument? So I think it is covered in your first week content, the name of the instruments which can give us the information about the below the ground. So what is hidden beneath the ground? Can anyone recall or remember that particular name of the instrument? Yeah. Okay. So no problem. So that instrument
Ground
is known as
LiDAR.
Ground penetrating radar.
so it's known as a GPR or ground penetrating radar, which is useful to measure the subsurface of the earth and for the subsurface geological surveys. So that will be useful if we have already existing town and we want to map out the pipeline or the drainage system under the city, then we can use this kind of GPR or ground penetrating radar through which we can map out the information which is hidden at the like below the surface of the earth. So that is our third question. Now we will move forward, and this is like LiDAR has an accuracy of, so LiDAR is the light detection and the ranging. So we can find out the distance between the two object or 2 points using the light. So can anyone give me the answer of you if you have remembered in the first week what might be the accuracy of the LiDAR scanners? Okay, fine. So this is a multiple choice options. One more than one is correct here. So accuracy in horizontal and vertical direction is given. Anyone else
Both
wants to?
10 to 15 centimeter both in height and horizon.
Okay. And anyone else wants to give the answer? Okay, fine. So the actual answer of this question is that 10 to 15 centimeter in vertical or in height and 30 to 60 centimeter in horizontal axis. So option C and D are correct. Why? Because like LiDAR is like light going and coming back. So the vertical accuracy is more compared to the horizontal accuracy. And I mean, if you want to do the exercise about it, like I mean, I think if some of you or near to you, of someone has iPhone with them. So in iPhone now, inbuilt LiDAR scanners are coming. So you can use a scanner and find out the like difference between two objects. Like you can measure the dimensions of chair, table, which is kept in front of you. So using one of the application in iPhones, you can use those sensors and measure the different tool like length or measurement units of the various objects. And then you can map out those same things with the using the tab measuring tape, and then you can find out the accuracy in both the way, like in terms of like horizontal and vertical direction. So that is one like you one thing you can do. Apart from that, I mean, if you go through the YouTube videos of one of the surveyor, which is known as Rama Tamimis or something. So he's like land surveyor in US, and he posts various videos of the various instruments or sensors which are having LiDAR or total station or robotic total stations which are available in market. And then he compares those kind of instruments, like what is the accuracy of all those instruments and so on and so forth. So that's it. I mean, you can do this experiment like if you are interested, and if you are having a nearby iPhone or if some other phone which are having inbuilt LiDAR sensor into it. So the right answer over here is 10 to 15 centimeter in height and 30 to 60 centimeter on horizontal. And mostly it focus on vertical accuracy rather than horizontal accuracy. So any question? Okay, so we will move to the next one. So the next one is like you have to arrange the particular method of taking the photographs, which is known as the photogrammetry, in the descending order of the photogrammetric technology development. So how the technology has developed from like low level to high level. So which option is correct? What do you think? Here below, one figure is also given. I mean, you can just look out and so can anyone tell me option C or D? Okay. So firstly, it starts with the graphical photographs. So we will use our notebook and pen, and we will sketch whatever is there. Then it like the analog time where we use this photographic films, and using chemicals we develop the photo on that particular film. And then we have analytical photography using the mathematical models and so on and so forth. And currently we have digital photographs which we can use in our mobile phones, laptop or computers. So like that it evolved from graphical photos to digital photos as of now. So from graphical to analog to analytical and digital. Now we have the next question that generally we take images, like if we want to survey any area, we take the images from the aeroplane or either from different airborne sensors. Let's say whether it's a drone, aeroplane or satellites. So what we do is we have kept our camera like this and we are seeing what is happening, like we are clicking the photographs. So if we want to take exact photo of the below surface, then we have to keep our camera exactly at 90 degrees. So just facing to the land. But sometimes because of the flight direction or some of the turbulence or because of any other reasons, it may get some of the tilt. So how much tilt is acceptable in capturing the vertical aerial photographs, which is 90° to the, like we are seeing from the top at the 90° down. So how much tilt is acceptable in those kind of conditions? 1 degree, 3 degree, 5 or 10 degree. 3 degree. Okay, so I mean the tilt which I am talking about right now, it's like this is the camera which is in airborne, and you are seeing exactly below the from the camera to the ground, and you are having some of the tilt. So this is the low oblique, it means the tilt is less, and here if the tilt is more, then you will get the more field of view. Let's say if you are clicking a photo in such a way that if you keep your phone like more tilted, what will happen that it will give more clouds, more sky. So it will capture the entire horizon, as you can see over here in the corresponding figure. So here, I mean, you can see the horizon over here. So if you keep your phone in such a way, phone or camera, that it will give you the maximum footage or maximum view, then you will get more view, but you cannot measure different things because of this like tilt, the objects will lose its original length and it will become like the objects which are near to you, it will give the perfect dimensions. But other than that, what are the objects which are far from you, it will be look like it is elongated. Then we have oblique, low oblique, so around like very less tilt. So up to 3 degree tilt, it is acceptable, and vertical means exactly 90 degree you are seeing. So, I mean, how it will look like if you are having it exactly 90 degree and then little bit tilt is there. So how your grid will look like, or how you will capture the different parts of the terrain. So basically the photographs are divided into two parts, aerial and terrestrial. So aerial is like we will keep our sensors or the camera or the anything which is capturing the terrain in the sky, and terrestrial it means we will keep those cameras on ground. In aerial, we have two further types. One is vertical and one is oblique. Vertical means you are taking exactly at the below, which is known as a nadir view also. And then if it is exactly at 90 degree, then it is a truly vertical. But if some tilt is there, then it is known as a tilted vertical aerial photograph. Tilted vertical aerial photograph. And 3 degree tilt is like it's acceptable. And then you have the another type of aerial photograph which is known as a oblique photograph. So there, I mean, you have low oblique and high oblique. So if it is low oblique, then it will not capture the horizon. If it is highly oblique, then it will consider the horizon. So now, any doubt in this question?
No, sir.
Okay, so we'll move to the next one. So now the next question is like the minimum forward and side overlap which is acceptable while doing the scanning through the camera or the drones. So how much overlap is needed? So there are two terms over here. First one is forward and side. So forward overlap, it means like you are capturing the uh, yes. So can anyone wants to guess the answer before we discuss it? What might be the answer?
25.
Yes, so it is like 60 and 25. So now, first we will discuss these two terms, forward and side overlap, and then their values. So when you are taking the images through aeroplanes or any kind of cameras mounted on the sky, it will like move in this direction, which is known as a flight line, flight path. And then when it is at point number 1, you will capture this area, or this tile you will capture, which is shown over here first. Then you will capture the second, and you can see here between first and second, this area is overlapping area between these two. Okay, so that is known as a overlap. And as it is going in the longitudinal direction and then in the forward direction as well, it is known as a forward overlap. So the overlap which is happening longitudinally or in the direction of the movement of the aeroplane or movement of the sensor, that is known as a forward pass or forward overlap. And that overlap is necessary, 60% forward overlap is necessary, as you can see here between the 5 and 6. And then once you cover one particular path, and then you will turn and collect the data of the next particular surroundings. So for that, it will happen that they will coincide with both each other, in the cross direction, in the cross section of the or the 90-degree direction of the flight path. So which is known as a side overlap or the lateral overlap. And that lateral overlap is necessary, but like it's 20 to 40% lateral overlap is necessary. So this is like all about the forward overlap and side overlap, and then their values. So forward it is like 60% is necessary, and side 20 to 40% is necessary. Now the question is, I want to ask you that why this overlap is necessary. So why do we have to keep some common area between two images? So can anyone answer me that why there is a need to keep some common area between two images?
So it will help to detect and correct the errors, like camera positions.
Okay, that is one thing.
To create a 3D image or a 3D surface.
Exactly. So, when we want to create a model out of it, so there using just one single image, we cannot create a 3D models. So we have to keep something common thing between two objects so that we can detect because when you capture these photographs from the sky, it is same like part of your jigsaw puzzle that you do not know how it will fit with each other. That it is just a single image, and then you have to stitch those images with each other so that you can make a combined mosaic, and from that you can make the 3D images also. So for that, we need a different images with different overlaps. So for that, this overlap is necessary. If you use some Google's web application is there to make a 3D structure. So in that it will ask you to click an object from various angles, and then it will merge those images and it will create a 3D structure from it. Same principle works with the drones. You will capture so many images which are having overlap with each other, and you will combine them and make a 3D image of your study area. So now we have our next question, which is angle of tilt is the angle between which two axes? So can anyone wants to answer it? Yes, exactly right. So it is the angle between the camera axis and the plumb line. So now there is the next question is what is the camera axis and the plumb line? So first of all, if we want to answer this thing, we should know the meaning of each and every terms which are written here. So let's say if you are having your camera mounted on satellite or some kind of airplanes or drones, it will see the city like this. So this is the axis of camera, and this is the plumb line, which is the line going in the line direction of the gravity, exactly down, which is known as a plumb line. So which is the line corresponding like 90 degree to the surface, and the angle which it is making with the plumb line and camera axis, it is known as the angle of tilt. And nadir line you also heard. So nadir is like whenever you are having your object from that 90 degree line, it's nadir line. So I mean this is the area of color. So that is just definitions of this particular various parts when you are capturing the image. Now I mean we will solve one of the question of scale. So when we capture the images from the satellite or the airplanes, it is not same as what we see on ground. When you create a map or take a photo, the size of the area will be reduced on a paper. Okay, so if you want to measure any kind of dimensions afterward, so you have to associate a scale along with that image. So in general sense, if I want to define a scale, so it means like you are capturing this portion A to B, and then like how much area, like how much length on ground of AB will be captured in the your image or in your photograph. So if line AB is representing 1 kilometer on ground, and what is the length of line AB on photograph? So the relationship between these two is known as a scale. So here you can see, if I want to find a mathematical formula for that, I will use the similarity of triangle, and then using that you can see that AO divided by capital AOA. So if we will take this triangle LA and OA, so this line AO divided by capital A OA, and then corresponding to that we have LO, which is L, and O, which is the focal length of the camera, and then L divided by OA, so which is like from the ground how far your camera is being placed. Okay, so that is known. So if I want to find out now, if I want to put the value of these terms, so LO is a focal length of camera, so which I know it's F. Then from LOA, if I want to find, so it is a distance from the object to the camera. Okay, so that is like, and this is the datum through which you are measuring all the vertical distance. Datum means a surface or reference surface through which you are finding out all your measurements. So this total measurement from datum to your camera axis, it is H, capital H, and from datum to this point A is HA. So if I want to find out the distance between A and L, vertical distance between A and L, then it will become the total is H minus HA. So I will start. So you can see if I want to find the distance between L and OA, it means that the entire distance, which is capital H minus small ha. So that will give me the distance between L and A. So over here like that, I will put everything in this formula. And here like AO is the length of the object in the map and AOA is the length of the object on ground. So that is known as a scale. So the ratio of the dimensions on map divided by on ground. So dimension on map divided by dimension on ground, that is known as a scale of the image. So from this, like if we put everything into a formula, then scale will become the focal length f divided by capital H, which is the height of the object, a flying object from the datum, so which is capital H, minus small h, which is the height of point A from the data. And if we have multiple images or some of the surfaces, then we will take the average elevation. So average, if I want to find the line AB, then the average elevation of line point A and point B, which is H average. So from this formula, if someone will ask you that find the scale if the focal length, height of the aircraft and mean sea level height are 10 mm, 1208 meter and 130 meter. So in question, it has been told that the focal length is of camera is 10 mm. So first F is given, then height of the aircraft, which means capital H, which is given 1208. And mean sea level height, which is 130. So mean sea level height means this HA is given to you. So which is 130. So you have to find out the scale of this particular image, or in this situation what will be the scale of the image which you will get at the end. So to do that, we will write the formula S is equal to focal length F divided by H minus H average. So over here we have F as a 10 mm and we want to find, like, put everything in meter. So first we will convert this mm into meter. So we will write 10 divided by 1000. Then height of the flight or aircraft, which is 1 H capital H, which is 1208 meter, minus this height of this from mean sea level or mean sea surface, which is 130 meter. So minus 130. And if you do the simplification of this particular numbers, you will get 1 divided by 107800, which is the scale of the image. It means 1 meter on image is representing 107800 meter on ground. So it is means 1,07,800 meter on ground, or in terms you can see 107.8 kilometer on ground. So 1 meter on map is equivalent to 107.8 kilometer on on ground. So are you clear with this numerical?
Yes.
Everyone? Okay, so now based on this, I will give you some of the numericals so you can practice it. So I will give you the time of 2-3 minutes and then you can do that numericals and find out the right answer. So now the first question is that an aerial photograph of a terrain having an average elevation of 1400 meter is taken at a scale of 1:7,500. That 1 meter on map is equivalent to 7,500 meter on ground, or you can say 7.5 kilometer on ground. The focal length of camera is 15 centimeter. Then the flight altitude above mean sea level is what? So you have to find out which variable you have to find out here. Can anyone say?
The capital H in the previous question.
Okay. Okay. So do the calculation and give me the right answer. You can tap your answer, like write your answer in the comment also. So I'll give you 2 minutes and just do the calculations and give me the right answer. So those who joined just now, we are solving this question
Sir,
where we
option
have,
2 is the right.
yes, option 2, yes,
2500.
2525. So we are doing this numerical where we have to find out the flight at which altitude we are flying the flight in such a way that the image which we are taking is at a scale of 1700, 1 raised to 7500, and the average elevation of the terrain is 1400 meter. So one answer we got 2525 meter, 2525. Apart from that, anyone else? Yes, Rakesh, you will go ahead. What is the answer?
2525.
Yes, right. So I think now we will see the solution. So first we will put the formula, which is the scale of an image or scale of a map is equivalent to f, which is focal length of camera, divided by capital H, which is a flight height, minus average height of the terrain. Then in question, the scale of map is given, which is 1 raised to 7500. Then the focal length is given 15 centimeter. So we'll convert then from 15 centimeter to meter. So that's why we are dividing it by 100. Then h is not given to us, and average elevation of the terrain is given 1400. So now we'll simplify this. We'll get h minus 1400 is equivalent to 1125, which will become the h is equal to 2525 meter. So how many of you are getting this answer? Please raise your hand in comment, like, or just, yeah. So is anyone is having any difficulty in doing it or solving this? Okay, good. If you have any difficulty in doing this, or if you are not able to understand the part of this question, please unmute yourself and ask a question. Okay, I think if there is no question, now we will go to the next question. So now the next question is, what is the aeroplane flying height to obtain the average scale of the photograph equal to 1 raised to 7200? Ground surface elevation vary from 160 meter to 430 meter, and focal length of the camera lens is 153 mm. So here you can see that it is similar to the first question, like the question which you solved earlier, like just before it. But here the average elevation is given that 1400 meter. But in this question, it is given that the surface which you are capturing, it is changing its elevation from 160 meter to 430 meter. So the catch is you have to first find out the average elevation of the surface and then after use the formula. So please do the question and we will solve it after 2 minutes.
Option 4, 3 and 4.
So those who joined just now, we are solving this MCQs from the week 1 content, which is based on the basics or the introduction about the course, then some of the tools which you use in geomatics engineering, and then some questions on photogrammetry, basically on scale, understanding different kinds of scale.
The answer is coming 1396.6, which is approximately the fourth option.
Fourth. Okay. Yes, nice. Anyone else? So here the catch is you have to find the average elevation, small h, which is not given directly. You have to find the h by taking a average of 160 and 430 meter. So 160 plus 430 divided by 2, and then use the same formula.
Sir, kindly show me the previous question. So I have.
Previous question.
Yeah.
Okay. So this is the previous question where we have average elevation, scale, and focal length of camera. And we solved that question using like this formula, which is S is equal to focal length divided by capital H minus average height of the terrain, where the S was 1 raised to 7,500, focal length was 15 centimeters. So we converted that into meter by dividing it by 100, because all the other units are in meter. Then H and then average elevation is given 1,400. So in this question, this HAV is not given directly. You have to find that by averaging the two values. Is it fine?
Thank you, sir. Thank you very much.
So now how many of you got the answer of this question? Yes. Okay, so it is answer number 4, 1397. So how we have to take the average elevation, which is around 295, and the focal length which is given here is 153 mm. But you can see the focal length is around 15 centimeter. Here also it was 15 centimeter, and here it's 15.3 centimeter. So the rough approximation of focal length is 15, around 15, 10, 12, or so on and so forth. So then after we'll put the average elevation, which is 295. Then after we have scale, focal length 153 divided by 1000, we have converted into mm to meter, and then scale is given 1 raised to 7200. Now once we simplify this, we will get around 1396 point something, 0.6 or something, which is approximately 1397 meter. So like this, you have to solve this question related to the maps and scales. So any doubt in solving these questions? Have you, like, if is there anyone who didn't get the concept of these questions, how to solve it? If not, then we will move forward and we'll do the next questions.
Sir, if
Yes.
sir, can I have another question. If something, any other changes will be there, any other twisted question will be asked like this. Any other format of twist, because here they twisted with the height
Yes.
and that max level. So it's
Yes.
any other possibilities.
So apart from this, I mean, I will go through the figures so you will get a more idea. So basically, we have to see here the formula focal length, capital H and HA and HB is given. So we are like, if you want to find out the for A and B, it is like you are taking the average and you are finding out the scale. Now, one thing which they can give is they will not give the scale, because in all the question either they ask you to find out the scale or scale is already given, but they tell like in such a way that the line which is of 10 kilometer is showing 1 kilometer in a map. Okay, so what they are doing is the line which measures 10 kilometer on ground is showing 1 kilometer on map. Now for this image is captured using the focal length of 150 mm. So find out the edge. So they have not given the scale directly. The value of S is not given, but from the definition we know that scale is a ratio of the two distances on map divided by distances on ground. So instead of S, what you can write is 1:10 or whatever is given to you. That 1 centimeter on map is representing 10 kilometer on ground. So you have to put both the units in same manner and you have to find scale first of all. And then start the question. So this kind of like change can happen. Apart from that, you can see here the main, like we are able to manage different heights using the concept of datum. So datum is an imaginary line through which we are finding the each and every elevations. So in some cases, they might tell you that the aeroplane is flying 1 kilometer above the point A. So here they have given directly H minus HA. So you do not have to find out the like H and H minus HA separately, because what we are doing is we want to find out the distance between L and OA, which is given to you directly. That vertical distance between the aeroplane and the terrain which you are measuring is 1 kilometer. And then after they will also tell you that the average elevation of the A is 1400. So people will, what they will do, they will just consider that 1000 as a H and then HA as a 2000 or whatever is given to you. Then you might end up with negative fraction. Or if it is like 2000, like from L and OA, it is 2000 and this is 1000. So what you will do, 2000 minus 1000 you will do, it will come as a 1000. But actually they have directly given to you H minus HA. So that they have given directly also that the distance between the spacecraft or the like a tool through which you are capturing the camera and the terrain is directly given to you. So these two kind of variations can also come. And one thing you have to keep in mind that make sure every units are in one particular unit system, either in mm, either in centimeter, or either in meter or in kilometer. Sometimes they will give you the distance of object on ground in kilometer and then corresponding length on map in centimeter or mm, because like that how we perceive the things. Okay, so this kind of changes might come in this kind of questions. Anything else?
Okay. Thank you, sir. Thank you very much.
Any other questions related to this concept of scale?
Sir, can you repeat again?
Okay, so basically, I mean, how they can trick you in this kind of questions. So first is normal formula is scale is equal to focal length divided by height of the flying aircraft from the datum. This H, capital H, is from datum. Datum is the surface through which you are taking the measurements. And then minus HAV. So the average elevation of the surface which you are measuring. So now in question, first what they can give you is either they can give you this informations F, H and AV, and they ask you to find out the scale. That is a normal question which is similar to this. The second question is they will not give you the H, height at which this aircraft is flying, and they will give you the other three information S, F and HAV. So find out the height of the flying object. The third way this question can go through is they will not give you this small h directly. Instead of giving this elevation of this terrain, they will give you the height of A and height of B differently. So what you have to do is you have to find out the separate like average elevation of AB or that surface. So that is the third way they can trick you. Either way, in the fourth way, they will direct give you this H minus HAV. So if they want to communicate their thing in a question, then they will ask that the distance between the aircraft and the terrain is given to you. That is 2 kilometer or 2000 meter or 2500 meter. So that thing will be directly given to you. So in that way also they can give you, that is a fourth way. Now after that, the fifth way they can change this question is they will not give you the scale directly. Instead of that, they will tell you the line on map which is having 1 centimeter representing 10 kilometer on a ground. Or they can tell you the bridge which is 3.5 kilometer long measures 3.2 centimeter on map. So first of all, you have to find a scale of the image or scale of the map. And then that scale you have to use over here. And the formula of scale, you know that it is the distance on map divided by distance on actual ground. Okay. And then next level like trick, if they want to do you, so they will give you the two different scales. So one scale is from map and one scale which you are having at this aeroplane. So I mean, what, like if you go to any survey of India site, you will find maps, and in that map the scale is written. That scale is representing that 1 centimeter is equal to 10 kilometer on ground. So first of all, you will find out the scale of that map. Then using that information, you will find the scale of this image, and then after you will solve this question. So I mean, this kind of variations can come. Any doubt?
No, thank you.
Okay. So I think we'll go now next. So now there is a question that if 2 points are given, that point A and point B, and their XY coordinates is given to you. So you have to find out the distance between the point A and point B. Okay, so I mean, this is the basic geometry question which you have learned in your 9th-10th standard. So can anyone say, tell the answer of this
The
question?
first one is the correct answer.
Yes. So the first one is the correct answer, where you take the x coordinate of point A minus x coordinate of point B, take the difference, do the square, plus y coordinate of point A minus y coordinate of point B, take the difference, take the square, and the under root of the summation of these two, which will give you the distance between these 2 points. But now the question arises, then when we quantify something, it might be different kinds of things. So this distance is known as the Euclidean distance. So the Euclidean distance is defined by the minimum distance between 2 points. As you can see in this figure. So if I want to go from point A to point B, what is the minimum distance between these 2 points? So that you will get using this formula, which is known as a Euclidean distance. But in real life, if you see the scenario, you will not end up by doing this. Instead of it, what you will do, you have to consider the road network if you want to go from point A to point B. As you solve the different maze, like in childhood you have done this thing, that you have one maze and one mouse is going from one point to another point, food is there, you have to solve that maze and that mouse has to reach to the another point of the square. So it's similar to that. If you have a network, you will trace that network and find out what is the optimal route between point A and point B. Is that clear? Now, in that, if we consider the modular approach, like we will consider these blocks. So here you can see, here in this coordinate system, every grid is at 1 centimeter distance. So from point A is having coordinate of 0, 0 and point B is having 5, 5. If I ask you the distance between this point A and B, which is 0, 0 and 5, 5. So if you use this particular formula, then it will become 5 minus 0 rest square plus 5 minus 0 square. So it will become 25 plus 25. So 50 under root 50, which will become 5 root 2. So the minimum distance between this point A and point 2, or which is also known as a Euclidean distance, which will become 5 root 2. But if you consider this modular approach, you don't want to go through like that. When you want to go through blockwise or the like using straight line, then you will go 3 direction like this, 1 direction up, then one more time 1 direction in horizontal direction, then vertical, horizontal, and so you are going blockwise block, and then you will reach to the point B. So if you go through this red line, then your distance will be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it will be 10 unit or 10 centimeter. In Euclidean distance, it is 5 root 2. But it is in, if you go through this blockwise approach, it is 10. So if you go like this, or if you go through this green line, then it will become as a 10. So here also we are finding the minimum distance, but using the concept of blocks, you cannot grow diagonally. So this distance is known as a Manhattan distance. You will moving in the 90 degree directions, and you are finding to the final destination, which is known as a Manhattan distance. And once you collect the data of various road network, or let's say river network, or any kind of network, and you want to start from one point and go to the another point. So as your Google Maps is using, you have to do some kind of network analysis, which can be done in this QGIS platform or any other platform which have spatial analysis tools. So if time will permits, then in this course we will also learn that if you have real-time data of road networks, how to find the optimal location or the optimal path between the location A and location B, considering the real network rather than using the Euclidean distance. So is that clear with everyone?
Sir, are there any appropriate formula to derive the Manhattan distance?
No, I mean you have to go through this blockwise concepts. So I mean in image, if you take, the pixels will act as this blocks. So as you, I mean you have to provide the directions, like way through which it should go. It will not like just putting an image. So there will be different algorithms. So you have to provide a path at least, and then using different paths, it will find out the Manhattan distance. So that is known as a coast path analysis. I mean, you will learn in this advanced, like in the upcoming lectures. So is there any question? So those who came late, for them, like we will just go through all the questions in this short time, so you will get a proper revision of it. And those who joined late, they can also go through these questions. And then after, we will see some of the websites of how to visualize different geospatial data sets. So basically, I'm a PhD scholar, like PhD student at IIT Gandhinagar, working in the Department of Art Sciences under Professor Vimal Mishra, and I'm working in the application of machine learning and deep learning in the flood forecasting. And I will be delivering this tutorial sessions of this advanced geospatial geomatics engineering every Monday on 7 to 9 p.m. So these are some questions which we discussed. The first question is on what task is not performed in geomatics. So geomatics is a measurement of earth and earth surfaces or various features which are present on earth. So it is not related to design and construction of structure. It is collecting the different geospatial data analysis of those data, developing tools from the data sets and software so that it can be useful for public. So the option C is wrong. It's not comes under geomatics engineering. That's why that is our correct answer. The next is ICT and IoT technologies are useful in geomatics engineering. Is it true or false? So it is true because we are using various softwares, tools to handle the various big data sets, like such as the satellite data sets or the GIS data sets. And then using those data, we are taking the decisions, communicating alerts and the other important messages with the nearby populations. And then IoT tools, it depends on various kinds of sensors which are available to monitor different environmental phenomena which are happening around you. So after that, I mean, we have seen the third question that terrestrial laser scanner cannot detect which kind of things. So we can detect the deformation, inclination, and sinking, but we cannot detect the buried object as it cannot penetrate through the soil. So that is not we cannot do. Now LiDAR has accuracy of 10 to 15 centimeter in height or in vertical direction and 30 to 60 centimeter in horizontal direction. So accuracy in vertical direction is high compared to its horizontal directions. Then advancement of photogrammetric tools. So from graphical we went to analog, then we went to analytical and then digital tools for creating the different photographs. Then the camera axis is kept vertical in vertical aerial photographs, but tilt up to which level is acceptable. So in vertical photographs, tilt up to 3 degree is acceptable. So the minimum forward and side overlap, which is happening while collecting the data through aircraft, is like 60 and 25%. 60% in longitudinal direction or the forward direction and 25% in the lateral direction. Then angle of tilt is the angle between the camera axis and the plumb line, which is this line, 90-degree line passing through the surface. And then the tail.
Sir,
Yes.
So nadir line, can you please?
So nadir line is the directly below your camera, and this plumb line is 90 degree to the surface which you are viewing.
Okay.
Then the next one is we have calculated the different questions on the scale when we have given the different types of focal length, height of the aircraft, and mean sea level height, and how to derive the scale using this formula, which is S equal to focal length divided by capital H, which is the height of the aircraft from the datum minus the average height of the terrain. Then we have seen some of the variations which can happen in this kind of questions, and we solved those questions. And then at the end, we found out one question, which is like how to find out the coordinate between two different points. Now there are some of the questions which is related to this concept. So I mean, you can try to answer this. So in map versus aerial photograph, due to this symbolic representation, the clarity of detail is. So in which of the following the clarity of details is high, whether it is high in photograph or on map?
Sir, can you please little zoom out? No,
Yes.
is not.
So what it is saying is, if you have two different things, one is map and one is image which you captured through the aircraft or drone. So in which image the details will be more? Details means whether you are able to identify the different features which are present on the earth. So in which of the scenario details will be high?
Drones.
Like whether it is details will be high in map or in photo.
Photos.
One answer is photo. And
Map.
is anyone saying map?
Map.
Yes. So we have two answers, maps and photo. So can anyone like tell the reason why the information is high in photo and why the information is high in map? I mean, can you justify your answer?
I was thinking the clarity of the. I thought the
Yes.
information about the clarity, so I tell the photos. But the information is
Okay.
more about it in the map, I think so. Can you please zoom out the screen? I can see the question
Okay.
clearly.
Okay.
Okay.
Sure.
Yeah. Thank you.
Okay. So I mean the answer is that clarity of details is more on maps rather than photo. So why the clarity of details will be more in maps? Let's say if some underpass is happening, that canal is passing through the like if you have seen that this on top river will be there and canal will go through below the river, or in some cases like the aqueduct or something, like canal is on the upside and then roads and the rivers will be at downside, down of the aqueduct. So when these two objects are intersecting with each other, so when we are capturing the images through the camera which are kept at the top, we will not able to capture this details which is there below the another object. Okay. Whereas on map, we can show that using the different symbols, that this is the underpass, this is the overbridge. So those kind of information we can directly represent on map because it has legends, which is like instructing you that consider this thing as a overpass or underpass. Whereas in photo, we have to use our brain, that whether it is underpass or whether it's overpass or something else is there. So we have to use our memory. But in maps, it is directly given on the legends. So if you have knowledge about that feature, photo will also give the same information. But if you do not have knowledge about those features, if you have never seen those features before, then it is difficult for you to differentiate. That's why the details, clarity of details will be more on map rather than photo. In map, you will also have scale, which will give you the measurements of the each and every object, which you will not directly get on photo, because photo is just you have captured one image. If you know the scale, then and then you can convert that photographic like information into units. So that any question or doubt in this question? Okay.
Sir, explain.
Yes.
Sir, the photographs rather than maps, sir. Although it gives the more details in map.
Yes. So I mean the question is like see, map is like if you want to, map is not like just it's like a map of city or map of district or map of India. Map can be for a small level thing also, like for a farm or for a small zone of the city. So it is not always like when you think about images, you will think about drone images, like which are very high resolution. Okay, that you can differentiate different things, that this house, second house, third house. But on map also you can do it. Like the differentiation between two objects is fine. But after that, if something is intersecting or something is below the another surface, this information is directly not present from the photo. I mean, it is there, but you have to interpret it. So you have to use your knowledge. That's why I mean details will be more in map. So I think after that, do you want to say anything? Okay, fine. So now the next question is, which of the following can be used as a map substitute? So if we do not have map, what we can use as a map? Now, first thing is map will give more idea, but if somehow we do not have map, and what we can use as a substitute of it?
Mosaic.
Mosaic. Okay. So what is the difference between this second option and the fourth option, which is vertical aerial photograph and vertical aerial photo, but mosaic?
Mosaic generally refers to the collection of maps.
Okay. So it's like we have different photos, we are stitching those photos and we are creating a map out of it. So mosaic, it means just stitching out the different parts of the images. Whereas this vertical aerial photograph, it's just a single photograph. We will not get more information other than the extent of that particular image. So we have to collect different vertical aerial photographs and we have to combine, make a mosaic out of it. So we have to stitch them together. So that's why the correct answer is vertical aerial photo, which is known as a mosaic. So any doubt till now?
No, sir.
Okay. So I mean, that's like I have kept this kind of questions till now. So now I just want to give a quick review from your side that what I mean, if you are joining every Monday, like what kind of content or how should we process in this tutorial sessions. So if your worst thing is like if you have any other questions or doubt, you can write in the comment sections or the Q&A section on the NPTEL website. One Google chat is there. So you can write down your query there. I will solve that query and you can also discuss that query during the every Monday 7 to 9 p.m. with me. But before it, just write on that, so I will be prepared with that particular question. Apart from that, if you want to learn anything or if you want to discuss anything, you are welcome. You can just mail me on my email ID and you can ask me the question in the Q&A section also. So in this PPT, I will share it on Google Drive. There my IDs and the other informations will be there. You can refer to that and get in touch with me. Apart from that, any other suggestions or anything which you want to learn more, or is it fine if we go through this way of discussing the different topics?
It's looking good, sir. We can go to like this. And if the recording section will be there or available, this recorder
Yes.
section. So where can I get it? This recorded session.
Recorded session. I will upload that on YouTube and you will get the link of that.
Okay, you are muted. Thank you very much, sir.
Anything else that you want to ask? Okay, also if you need to like learn any other thing, other software related to that, so we'll discuss that as the course progress. We'll deep down using QGIS and Google Earth Pro, which will give you the more clarity on understanding the data sets in geospatial technologies. So that thing we will do. Now I will show you some of the smart city portals which are in use currently. So I'm currently living in Gandhinagar, which is situated in Gujarat. So here the municipality has its own geospatial platform or the one web page, which is Gandhinagar GIS, the Geospatial Information System. So in this, like wherever there's smart city, there is a highly need to manage the different facilities which are available within the city in optimal manner. It works similar to Google Maps, but it has inbuilt different facilities which are available within the city, such as that different medical stores, offices, parks and gardens, police stations, movie theaters. So different kinds of informations are available over here. So what we can do is like if you want to get any information about the theaters, I will go and click on theaters, and it will open up this kind of portal where you can see the map of the Gandhinagar city. You can see it is it's a like planned city, so you can see the different zonation of the city. It's in terms of blocks, and then one river is passing through this, which is Sabarmati River. Over here, the IIT Gandhinagar campus is there, and then here in this part of the city, it is showing that it is not like a planned, or it is not in zonal, it's in zones. So it is like the development which happened after the construction of main city. So in the outer area of the city, they are constructing the building haphazardly and not in controlled way. So I mean, you can see this type of informations. Now you can see this particular symbols of movie theaters. I mean, like this, you will get all the informations. And then over here on the right hand side, you will get the details about all the theaters. Let's say you want to get more idea about any particular theater, just click on it. You can get the direction of it, view details, what are the different facilities which are around this particular theater, like how many ATMs are present, or is there parking facilities are available, or public toilets are available or not. So that kind of thing you can search around this. Similarly, I mean, you can have, this is information about the theater. Apart from that, I mean, you can have the temperature also, the climate information as well. And then you have upper toolbar, which shows you can put the different layers. So you can put the government educational buildings. So let's say Anganwadi, college, library, and schools. So you just click on any of the one which you want to visualize in the map. So once you click, it will show you all the Anganwadis which are available. Similarly, government colleges which are available, then public library which are available in the city, and then government schools which are available. So you can find out the, if you are living in some of the area, which school is near to you, and how are the different facilities are located in your area. So when we talk about smart city, I mean, we have different facilities. The one is the education. Then the second one is a public utility. So where you have different advertisement boards, that if n number of advertisement boards are available in the city, let's say 50 advertisement board. Now if someone wants to advertise their particular product or for political purpose, so where they can put the board or they can put the holdings in a such a way that they get the maximum view attention from the people of the city. So which are the surrounding areas? So we have to find out the which are the area which are being like populated, like roads are busiest road. Then which are the area near to the malls because people visits those areas frequently. Which are areas near to the theater. So we have to put different layers, and then we have to carry out a different analysis based on the collected geospatial data sets. That now if some kind of fire happens in a particular theater, so which is the fire station is nearest to the that particular theater. If fire happens in a school, then how far the fire station is and how much time it will take to respond to the emergency. So that kind of questions you can answer using this kind of smart portals. Apart from that, in public utility, you have commercial areas, government offices, hotels, monuments, museums, panchayat office, park and gardens, payment centers, petrol pumps, police stations, post office, restaurants, swimming pool, and theater. So the question is, if someone asks you to build a smart city portal, so first of all, we have to find what kind of things we consider as a smart city, what kind of features it should have, make a list of it, and then how to visualize visualize those facilities, how to categorize them. So there's kind of things we do. Now we have the boundaries. So the cadastral boundaries also it's there. The like entry point of the city boundary, then the survey boundary for ward wise boundary, or you can see here, if we click on the ward wide boundary, it will give me the boundary of each and every wards. So how to manage different kind of waste in each and every ward, which ward is clean. So even ward wise management we can do using this smart city portals. Then if you have divided your city into different zones, like north zone, south zone, so this is the zonations. Then this is the city boundary, which is already been there. Then after, you have financial services which are available in the city. So under that, ATM and banks. Then private health centers, so blood bank, medical store, pet clinics, private hospitals. Then you have transportation facilities. So where is the bridge? Then where is the bus stops? Where is the divider, footpath? So all the information you will get. So where is the different kinds of bus stops? Then where is dividers are there, so you will get all those informations. Footpath. Then G bike is means if you want to rent a bike, so where you will get that bikes. Then parking area, parking, railway stations, railway track, road center line. So this is the data which you can include under the transportation sector. Then you have properties. So over here, the footprint of the building, cadastral boundary of the each and every parcels of the or the your uh, like legal boundary of your building or plot. So that thing you can also find out the plot numbers. Then how much property text that like is remaining at that particular locations. So you can just click on that and it will show you the in-depth details about it. So then after you will go zoom to the any particular parcel, and then you can go through and you can check out the different things. Here it is different tools are given that know your property, how much text it is there, and so this kind of things you can do, and how they have divided the different types of land parcels into different like parcels. Then you have service utilities where containers and toilets are there. Then town planning, so contour, final plot, Gamtal area, LULC, original plot, reserved plot, structural layout. So these are the different town planning aspect of the city. Then government health centers, so as we have primary health center and government health centers differently. Then smart city, so it should have like smart sense in sense of monitoring the environment, noise level, air quality level. So which are the environmental sensors which are part of IoT devices is there in the smart city. Emergency panic location, so if flood or earthquake will come, they will communicate this message to the nearby area through this kind of locations. Then smart poles using the sunlight, like solar sensors, they will run the smart poles. Then the environmental display boards, the smart street light, surveillance camera, traffic controllers, vehicle detection camera. So all of this are the comes under the IoT devices. And this portal which you can see is a part of ICT tools which are needed in processing the geospatial data which you collected through geomatics engineering. Then you have waterworks, which includes the drainage line, tube wells, sumps, then other valves and other things. So you can see if I click on tube wells, it will show me. I'll just turn off this layer of property text. So you can see the different now tube wells as well. Apart from that, private educations, so private colleges, private libraries, and private schools. And then at the end, you have sewerage system of the city, which is sewage line, manholes, pumping stations, treatment plants. So all those are the manholes. So if something like will choke, so where to go and from where to investigate start the control, doing the operations, so that you can find out. Then sewage treatment plant, where are those located? Then strong manholes. So these are the strong manholes to collect the water from the rain. And these are the storm water lines. So how that lines are moving. So these are the component of a smart city. and I mean you can integrate those portal with each other, and you can create a system, GIS system, in such a way that you can manage your city in a very planned. So these are the layers which you can visualize in this portal. Apart from that, I mean you have different smart city component. So traffic controller, environmental sensors, so environmental panic locations, so all those are the panic locations. Then the smart street light, so vehicle detection cameras, so everything you can see from here, Wi-Fi locations. Apart from that, data about the population is also given. Then you have different queries. So if you want to search that, find out the school from my area, or how many schools you can cover through that one particular fire station. So those kind of queries you can also do. Then what are the services that Gandhinagar Municipality Corporation is giving? So planning of any event, tax collection, toilet finder, disease information, G-bike, bean locator. So I mean those kind of things also you can do. You can click on this assessment book where they have everything, like you have to enter your PIN code and then it will give the, like, enter the property identification number to verify your property tax in property tax register, and after entering the property in identification number, it will show the number of bills that will be available for your plot. So that thing you can do. Apart from that, near me, it means in your proximity what are the services are available. So from your area in 2 kilometer what is there, 3 kilometer what is there, so like that you can find out the various facilities. Then direction is like normal direction which you see in Google Maps. Know your property. If you want to know something about your property, you can click and you can find out the different things, your plot number, details, your who is owning the that particular plot. So those things you can note from here. If you have any complaint or grievance, so you can do that, register that using this tool, and then announcement if any are there, they will circulate through this. So this like way like you can create a GIS platform for smart city, and you can do a lot of take lot of decision for the, whether it is for disaster risk reduction, for handling COVID, or any other thing, or any other decision which affects the people who are living in that city and the administration who is controlling that city. So this will help full in select like taking the various decisions related to the different facilities which that city is offering. So I mean, any questions about this smart city portals? How will they look like? This is an example of Gandhinagar. Apart from that, Chandigarh I think is having, Pune is also having. So I mean, you can see the smart city portals in India. You can search that smart city portal Pune, I think. So here the first website is called Pune Smart City Portal. So Pune is also developed. So I think it's a lot like here they have given multi-purpose hall, smart market, swimming pool. So these details are in terms of reports. You have to convert that into a GIS platform. So fire station with disaster messaging. So all these things are given, but you have to convert everything into a GIS portal. It might be here only. We have this. So now so many cities are developing their portals like this web-GIS. So GIS portal for smart city. So I mean, so if they do not have, if this portal of Pune is look like this, you can see here that they are also in different layers related to health, public convenience, financial service, public phase, education, traffic, parking, infrastructure, bhavans, historical buildings, slums, sports, land use. So like that, I mean, you have everything and how to use those tools. So this is kind of manual. So I mean, like this, you can explore the various smart city portals, and if you can take the different decisions if you are working in that particular area, if you want to construct any structure around that, so what kind of things you can consider. You can search more about this smart city GIS portals, that which kind of smart city projects are there. Any other doubt or questions, or if you want to ask anything? Is there any question? Someone has raised their hands. Do you guys have any questions? Any questions? Okay, if not, then I will show you one of the website of Government of India from where you can collect so many datas like this. So that data is created under the Pradhan Mantri Gram Sadak Yojana, which is known as a PMGSY. So there is a scheme known as Pradhan Mantri Gram Sadak Yojana. So under this Yojana, they are creating connecting the different villages with the towns and the surrounding community. So if you see this website, Pradhan Mantri Gram Sadak Yojana, so here, I mean, you can see the different networks in that they are working, different phase, their abstract, their proposals, and then progress monitoring. And if you go down, so you have the different dashboards which is show you the progress of this particular scheme. And then, I mean, you can see the different state, like what is the completed length till now and completed connected habitats in 2024 and under different years as well. And if you want to download the data which they have generated under this, then so these are the segments that they have done. So for that, like for downloading the data sets, they have created one portal named Geosadak. So which is a Geosadak is a GIS platform where they have collected the data of various facilities, road network, and they have kept it for various states. So you can select any states, then you can select the different layers. So let's say I can select the Gujarat, and under layer you can have facility, habitations, then roads which are constructed under Pradhan Mantri Gram Sadak Yojana phase 1, phase 2, phase 3, and different proposals under vibrant village, Pradhan Mantri Janman Yojana, candidate roads, then detailed reports on the roads. So you can select any of the layer, and if you want to know what that indicates, you can click on details, and you can see that under facility it includes the marketplace, hospitals, schools, and transportation facility. Under habitations, like cluster of population living in that area, and which does not change over time, so that information they are having, and these are the parameter that file is having. Then these are the different proposals. So list of road works to be taken up under the Pradhan Mantri's flagship scheme, Pradhan Mantri Jannanti Adivasi Nyai Maha Abhiyan. Apart from that, you have different things. So you can read about those data sets in detail by clicking on more details. Then you can select any of the data sets facility. You can enter this CAPTCHA code and then click on accept term and condition and download the data sets. So like that, you can download the different GIS data sets. Once you download this data set, you can open this data sets into any GIS software such as QGIS or ArcGIS. And then after you can do different kind of analysis. You can also import your own data sets which you collected using drones, LiDARs, GPR, let's say pipe network or something. And then you can integrate those data with this kind of information which you got from this kind of portals like such as Geosadak. And then you can create your own particular portal for website which will give you the more idea and which will help you to take decisions. So in like this is just a one way like how India is going to in the world of geospatial data science, and they are having this under this national geospatial program. They are conducting so many workshops and different hackathons related to this geospatial data which comes under the umbrella of geospatial engineering. So there you will use different tools and technologies and you will create some applications which is useful for the public, which will help you to take decisions on time and accurately to fight the disaster, COVID or any kind of diseases. So understand this partial and temporal variability which is happening in your area. So I mean, we will go through the different kinds of this kind of websites during these tutorial sessions along with the solving the questions. So you will get to acknowledge like how we have developed in this science or geospatial science and at which point we are till now. So we will like explore those data and how to process the data in the subsequent lectures as well. So before that, any doubt?
No, sir.
So, I mean, is it like boring or are you able to learn it? I mean, the concepts and the supporting things.
No, sir, it's really interesting.
Interesting, sir.
Okay, so I mean, we will discuss a lot. If you want to know more about this subjects, just let us know. We will try to cover each and every application. So if you are from structural engineering, if you are interested in water, transportation, or any, if you are not from civil also, I mean, you can learn more because this technology is like in each and every domain. You can take any of the domain and is like applicable. And there are so many opportunities which are coming in this particular area which you can explore afterward. So we will discuss that thing in detail in the subsequent lectures. And meanwhile, if you have any suggestions or comments or critiques, please do not share with us on Q&A section of this NPTEL course, or you can mail me also if you want to learn something. We will discuss that thing during tutorial sessions.
So please share your email ID.
Sure. So I will share this PPT. In that, my details will be given. Okay. So if there is no doubt, then I think we can now close this session.
Sir, where will share this PPT?
I think you will get this on this NPTEL site only. The discussion session is there. On that, you will get the link.
Okay. Yes.
So if there is no question, I think we will end this meeting here. So thank you all for joining and we will learn a lot. Until that, just keep mapping. Good night, everyone. See ya. See ya on next Monday.